Welcome to Today in Space. We're back for another episode. As always, I am your space science podcast host from the East Coast, Alex Giorfanos. And this week, we are talking to two young co-founders of a company called NAVXCOM. I just wanted to thank the team for reaching out, for wanting to be on the podcast. We love talking to these young companies that are just starting out and of any size, right? And there's so much that needs to be done in space, and one of the things that we can do here on the podcast is bring those conversations to you so you can hear about these different companies, so that these companies have a chance to get out there and talk about their message, and just so that we all get a better idea of what's out there in the industry. For anyone that is new to this podcast, I went to school for aerospace engineering, and when I first was trying to get out into the workforce, I didn't have many examples of what was out there, the different companies, the different jobs, anything like that. And after doing this podcast and talking to people like Matt and Luca here, we're going to talk in a second, you get to find out more about the industry and the different paths there are. And this is a really unique one. Both these guys have had great experience within NASA, and now they're taking that experience outside. They just have a great understanding of how the industry works today. I am really excited to bring this conversation to you. We thank you for joining us here on Today in Space. And as always, please make sure to follow us on social media, whether it's Today in Space Pod on X, Twitter, or Instagram. There's Today in Space on TikTok. And then, of course, we've got our email at todayinspacepodcast@gmail.com. So go check those out. Make sure to subscribe to the show. Share it with friends or anyone else who's a space nerd or even just a casual space enthusiast. There's room here for all of us in our mission to spread love and spread science. So, without further ado, please welcome Luca and Matt, the co-founders of NAVXCOM, for an episode of People of Science. Let's get to know them and a little about the company's mission and what they could do for the future of lunar travel. Thanks for joining us. Welcome, everybody, to another episode of Today in Space. We're here today to talk about the next stages of going to the moon, and we're going to talk to some people who are working on the next thing that we need up there, and there's many things we need in the moon. It is such an uncharted place for us as humans. Haven't been there in a long time, and the last time we were there, we were only there for a short stay. So if we're going to be there long term, if we're going to live and work in space on a daily basis, we need things like infrastructure, and there's so many things that we need. And today, our guests from NAVXCOM, the co-founders, welcome to the podcast. Gentlemen, please introduce yourselves, and thank you for joining us.
Yeah, thank you so much for having us. My name is Matthew Onassis. I'm one of the co-founders of NAVXCOM, and I am going to be the CEO of the company once the company is larger, and that makes sense. A little bit background about myself. I had my bachelor's in tourism management and a master's in space operations, so I thought that would be a cool amalgamation of the two for space tourism. But I am mostly passionate about deep space infrastructure, and that's why we have NAVXCOM. Luke, do you want to introduce yourself quickly?
Absolutely. Yeah. Hello. Thank you for the introduction. My name's Luca, but you can call me Luke. I am one of the co-founders of NAVXCOM, and I'm also going to be the COO once the company is going to be large enough. A little bit of background about myself. I have a bachelor's degree in astrophysics, and I come from a research background. And so my passion is just understanding the universe and getting there to answer the big questions.
And it was great, your team reached out to us here, and we got to have a little bit of chat beforehand and get to know each other. And I got to say, we really connected on a lot of really cool things about where the future of space could go and what you guys are working on. So before we get started, because we want to learn more about you and your STEM origin stories, tell us about NAVXCOM. What is it? What are you guys trying to solve, and what's your mission here?
Sure. Luke, do you want to answer that? Or do you want me to get it
Definitely.
started?
So NAVXCOM was born within the NASA environment. That's where Matt and I met. And that's where we identified the gap that NASA was trying to fill within the LunarNet infrastructure. NASA defined LunarNet as a set of standardized rules as to like what we're going to need in infrastructure in terms of like networking for navigation and communication on demand. And so we came up with this idea, and after a NASA experience was over, we decided to open a company and take it to the next level, bidding for a contract at NASA Marshall Space Flight Center. And we actually won that contract, and we are working with them to establish the first proof of concept, which is going to be done by the end of this year.
That's awesome. So let's break that down real quick. So you guys met um, in a NASA internship program, is that correct?
That's correct. Yes.
Could you guys tell me a little bit about that experience? I feel like that's such a cool pathway for people to enter NASA and then have these opportunities like you guys are having right now.
Sure. Yeah. I think NASA has at least dozens of different internship programs, if you will, uh, through universities, through directly through themselves, and also some other, I guess, larger companies. Let's say, for example, fellowships, if you want to study for your PhD, for example. I think the opportunities are huge, and pretty much everyone who wants to get there and learn how NASA does things in terms of programmatics, as well as like STEM related uh, activities, you can definitely get there. It's not a matter of like if you see someone who's done an internship at NASA, that doesn't necessarily mean that person is just super unique or
Mm,
a super smart person. It's just a matter of, hey, do you want to learn? Do you want to challenge yourself or not? So we've done it. We've actually done both two internships, and that was kind of like a collaboration with Arizona State University. We've done one internship which was about proposal writing and what I guess like elements of the proposals are and how they evaluate each proposal, regardless of what level it is. Even if it's like you want to get some sort of contract with DoD, it's very important to learn how these contracts work, especially for people with STEM background that they don't have business background, they don't know much about finance and
mm,
program management and stuff like that. So that was fantastic for those group of people who were very technical, and they've learned they were actually surprised of like how important it is to include your program management, your schedule, your budget, and stuff like that. And for the most part, those people who are at NASA or anywhere else uh, evaluating those kind of like proposals or contracts, if you will, uh, it's very surprising for those people to know how important it is to include those kind of non-technical elements to your
mm,
proposals. And a lot of people who are evaluating these things, they're actually these proposals, they actually don't have that much of background in let's say physics or mathematics or something, or they might just have some sort of background in one uh, branch of STEM, but not on the other on the others.
right.
So that's why it's so important to know how to write proposals. I guess you got to know what technical writing is and stuff like that. So that was one of the internships that we've done. And then the second one was more of technical. So we work on uh, this project, which now we took it to NAVXCOM, and we're continuing it. But I think the base of it, if I'm not mistaken, that was about series, right, Luke? Uh,
Um, uh, oh, Sarah's the Siren Man. Oh, no, that was, I think we worked on two different projects because I worked on planetary defense. And you worked like in the exploration of like Ceres, well, not Siren Man, that's on Jupiter. Um, that was, an opportunity to learn, how NASA creates missions from the ground up and how they are executed, which was
Mm,
very interesting. We had the opportunity to talk to people in the sector, both like government and commercial. So it was an amazing opportunity to learn. And then when we took it to the next step, was when we proposed our own idea and it got approved. And then we decided to uh, go into the industry route and yeah, start a company that proposes.
That's pretty cool. I mean, you guys basically got like incubator trading, right? Like you were basically prepping for what you guys are doing right now. So that's
Yeah,
very cool.
yeah,
Exactly.
yeah,
We actually incorporated a lot of those, I guess, those things that we've learned through the internship, and we're using a lot of those concepts, a lot of those Excel sheets, and
Yeah,
those things that we already got. We saved them up, and
totally.
we're now reusing them, especially for, let's say, programmatic, for the budget side. They're
Mm,
super cool, Excel sheets with a lot of experience that NASA for the past like 40, 50 years, they were putting into this kind of like Excel sheets to see how much of, how you have to manage your budget, what are the elements, and how you're going to prevent, going over budget and stuff like that. So these are like
mm,
absolutely free tools that we got that we could just work in some companies for 10 years to learn these things. And we just learned that in
yeah.
like 8 months of doing that internship with NASA. So it's extremely important actually to do these kind of internships free of charge, and in a very short period of time you're gonna get there.
Yeah, and you've made the relationships on the inside and you know how to speak the language for funding, which is it's a whole other world, like you guys were saying.
Yeah,
Um,
yeah.
absolutely.
mm,
Yeah, that's how we got like our foot in the door, like to pitch our proposal because what we do is actually this is still like a fully funded NASA project for now. So the principal investigator is actually a NASA person right now. And we got the foot in the door because I mean the director of the program that we did the internship in is actually the CTO of NASA Marshall Space Flight Center
wow.
down in Cambridge. So yeah, we contacted every NASA center in the nation, and I mean as soon as we contacted like NASA Marshall and John and Kennedy said, okay, I can get you guys and then you can bid and see if you guys can win.
That's awesome. So tell me about the period of transitioning out of the program and taking the project to become NAVXCOM. What was
Mm.
that like? Was there a specific day or a moment where you both it just clicked for you guys, or had this been brewing for a while?
I think after the program, I just reached out to Matt on LinkedIn and I said
Hmm.
I wanted to take it to the next level. And I messaged the team members and most were like, yeah, sure, we can keep working on it, but like, yeah, not as commit they were not as committed as Matt. So Matt just like I messaged him and immediately took it to the next level and he's like, okay, let's start a company, let's go like um full throttle on it. And I was like, yeah, this is exactly what we need. And I
Yeah,
started looking for, yeah, I started looking for contracts right away. And there was the Center Innovation Fund, which was due that summer because we finished in May.
Hmm.
And so, yeah, we started contacting NASA centers and NASA Marshall responded, and we had the opportunity to bid with them. The technology, in terms of like the what we developed in those 6 months and that month that I worked on it, the technology like really matured and improved. Because
Hmm.
I mean, to be presented on a proposal, it had to be like completely like way more granular and way more detailed. So
Hmm.
yeah, there's like long days and nights of like research and like uh, writing down the sections of proposals and scrapping it and doing it again.
Hmm.
And yeah, so yeah, we just submitted it. It was a two-phase proposal,
Hmm.
um, which I think it's less stressful, in a sense.
And what does a two-phase proposal mean?
Basically, you just either you got like, it's like you either get through phase one and you can access phase two,
Okay.
or if you don't get through phase one, you're done basically. But I
Is the
say
funding like gated in that? Like if you get to phase one, you unlock, more funding for phase two, or how does that work?
no, usually you're out if you in the in
Okay.
the early stages of the two-phase proposal. If you don't pass phase one, you're out. But I think
Okay.
it's more you have the opportunity after you pass phase one, you get feedback, and you have the opportunity to like
Mm,
improve your proposal even further for phase two. So even when you start the project, you start the project with more confidence than you would have
mm,
just from a directly phase one proposal.
gotcha.
Yeah, I think that was not a surprise for me because I've always wanted to become an entrepreneur.
Mm,
So I actually started another company, another corporation, and I just didn't have nobody to help me with. So I started working on, the finance, the business plan, and putting the
mm,
pieces together and looking for funds. And then at that time, Luke just sent me this message, and actually he sent that message to pretty much everyone in that group that we were. I think we were a group of like 8 or
mm,
something like that, and so everybody just pulled back, and then we just stayed in the company. We were waiting a long time for a lot of other folks to join us when we were doing when we were opening the LLC, and nobody wanted to join. So for whatever reason, but we just kept going, kept going, kept going, and we got better and better. Stronger. We tackled a lot of issues, a lot of bottleneck that we had, and we learned a lot. So we're not perfect still. We will never be perfect. Nobody's going to be perfect, never ever. But it's just a matter of tackling those issues and solving the challenges that appear. And yeah, like I said, even if someone has 40, 50 years of experience as a CEO of a company, they're still tackling issues on a daily basis. And that's
absolutely.
the whole thing. Maybe that would be at a different level, maybe at a different magnitude, but we're getting there. We're definitely getting there. Especially me, I'm coming from a business background for more than a decade. So
Mm,
I've been through all these kind of issues before, so I know. But this is kind of something new for me. Aerospace is new, and that's going to be the home for me forever. And I will never, ever, ever be able to transition to another industry. Yeah, anyone who transitions to the space industry never ever want to just pull back and go to
mm,
another industry. It's just so awesome. And like we were talking about before, the space industry is not boring at
mm,
all.
mm.
Maybe you're working on some for some people, maybe satellite industry is a little bit boring in some part of it. But for the most part, especially if you're getting into lunar operations, human
Mm.
space flight, like who gets bored of human space flight?
Yeah, totally. Totally. It's so much fun to see how much things have changed in 10 years. I think we had talked about that before. Like when I was looking into when I was in my aerospace engineering degree, 2008, 2000, to 15, like we lost the big program of the space shuttle, and then there really wasn't anything, we were still figuring it out afterwards. And you think about where we are today, where we've got rapidly reusable rockets launching almost, what, 3 times a week out of Florida, and I mean, we have so many spacecraft to keep track of. It's amazing. So what is it right now that excites you the most about the space industry?
Me personally is that we can feel that we're into like an into the dawn of like a new era for humanity.
Mm,
We're starting to our journey towards becoming like a multiplanetary species. And we're setting the first steps to get there. The government are set on it, and the industry is set on it. There's a lot of synergy going on between these two worlds, which were like very different just
yeah, they're
like
like
10
oil
years
and
ago.
water. Yeah.
Yeah. Now there's starting to be a lot of like synergy.
Mm,
Things like NASA and other like government branches are like starting to like fund more and more startups. to like have a pool of like different ideas and different like angles to like tackle problems. And so yeah, these are definitely like very exciting times, and to be a part of it and to be developing something as significant and important as like the lunar internet and like GPS, which like GPS is not the correct word. We actually called it LPS, Lunar Positioning System. It's not
Nice.
trademarked, but
Nice. I like LPS. That's
With that
great.
R sign, with that R sign. Yeah,
um
I think Yeah, I think we're in a pivotal moment, as Luke mentioned. Uh, just like, 20 some 30 years ago, the internet was nothing, and no one
Yeah.
thought that, internet is gonna be, you know, the new enabler. Um, we believe, and I personally strongly believe that we're in that moment. We're in that pivotal moment that, in the next 5 to 10 years, if you're not getting into the space industry, it's going to be too late. So
Mm,
that's where we're getting in there. And I think a lot of great stuff are going to happen in the next, like I mentioned, 5 to 10 years. So if you're getting now, you're going to be one of the major players in the future.
mm,
It doesn't mean that at that time no one's going to be able to get there, but it's just going to be much, much harder. So get your
right.
feet there as soon as possible. Is going to be pivotal. There's going to be an evolution in terms of industries, and I think that's the final destiny for humans. That we want to be among stars, and we're getting there. We're still, type zero civilization, but I don't think, type one civilization is going to be too far. People are talking about 1,000 years or something like that. Some people more realistic 100 years, but I think it's going to be much, 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 much earlier than that. I think in the next 30 to 50 years, we're going to get there with the rapid changes in technology, especially AI. But
Yeah.
yeah, it's very exciting, super exciting.
Yeah. So, I mean, there's so much to go off of that, but I wanted to just go back to this, just to make sure we gave it its time. So, lunar positioning, right? GPS on the moon, internet connectivity. Um, where is it at now? I'm sure I could give an explanation of it. I know we've talked about it before, but I'd love to know, you guys are working on the problem. Where is the moon today as far as that stuff?
yeah. As far as like the current like state of the art, I mean um there's no significant state of the art to relate to. I mean, we can look at what happened with like recent lunar missions, which unfortunately like they landed on the wrong spot and they tipped over, and
Yeah.
some like instrumentation was not able to like complete their experiments. So as far as like navigate, even for Mars, I mean, navigation is done through like either like Doppler
Mm,
effects, like signal gets sent back to Earth, or visually. And that
crazy.
is, yeah, and that is not the most efficient way to go for like autonomous operation, especially if we want to go big scale for a
Mm,
big scale like colonization. We need precise GPS and man to like support autonomous operation and also like autonomous spacecraft landing on site to like ensure that the colonization happens in a
right.
fast and secure way.
Yeah, routine
I think the
supplies.
current
We're not worried about, launch pads getting blown up because it didn't hit it right or anything like that. Yeah.
Mm. Yeah.
Yeah, sure. I think that even the current infrastructure, I think it's not even supporting the current missions, let alone the future missions that hundreds of companies and countries and agencies they're going to be collaborating.
Mm,
We see that, and that's our, we envision in the future. That's the whole thing. If you can envision the future, you will definitely be a part of it because you know the value, you know what's going to happen, and you will get there. So yeah, I mean, like I said, the current infrastructure doesn't even handle that, let alone the future operations, and that's why we found this gap in the LunaNet framework, and we're feeling it. There are so many other competitors. Actually, we don't really like to call them competitors. We actually want to work with everyone,
mm,
but there's so many other, I guess, solutions. That's a better word.
mm,
Uh, but they're not there quite yet, and I think they will get there. but without a system, without a surface system like our systems, it's just the operations are not going to be efficient, and not many companies and countries cannot collaborate with each other efficiently. So at that cost that we're developing these systems is definitely enabling a lot of new companies also coming to the lunar operations and the lunar economy. So yeah, definitely, like I mentioned, there is no uh, infrastructure so far built into the navigation and communication, especially not in the navigation part of it. So maybe a little bit of communication here and there, surface to surface. I'm sorry, not surface to surface, but surface to satellites, and those kind of lackluster, communications with delay and kilobyte per second of data transfer rates. But yeah, we're talking about gigabytes per second per client.
Crazy.
So yeah.
That is a real step forward. I mean, I think if I remember the story correctly, during the Artemis mission, Artemis 1, they released a few CubeSats, and even those CubeSats over helped overwhelm the deep space network at one point. They fixed it, but like that's kind of the level where we're at. It's just like I think we're seeing some of this in the US. There's certain places where you're just seeing roads have completely fallen apart. We've seen bridges fall apart here, like infrastructure and keeping that stuff up is one thing, but when you don't even have it to then maintain it, it's a whole other thing. So going back to the ground-based tech, can you dig a little bit more into the approach that you guys are taking that makes it different than everybody else?
Definitely. Yeah. So what we want to do is make it fully autonomous. So fully autonomous deployment so that it can prepare the timeline and prepare the like lunar surface for like ultimately for like lunar arrival.
Mm,
So basically like support operations where they will need to be done, either like South Pole or like one of the uh, seas on the near side of the moon, or even the proposed telescope on the far side of Maine. That's very exciting. But what we need to do is like an autonomous deployment. So no human is going to be required to like set up the infrastructure, and
that's
it's going
big.
to be able to and it's going to be able to support like operations autonomously and getting like even habitats ready for like human arrival and
Mm.
also for human arrival, making sure like the spacecraft is going to land very safely on a prepared launch pad.
Mm.
So yeah, that's going to be very important.
No, that's great. I think so much of the, going to the moon and even the argument, against something like going to Mars was, you know, the equation was always, well, you have to build everything and send humans and put them together. It'd be nice if you had a rover, but, you know, building a Mars exploration rover each time is just not, feasible for scaling all of this. Um, So, what does the autonomous stuff look like right now in your planning stages? Are we launching, say, a swarm of these in a payload? Are they that small? What are we looking at?
Yeah, that's kind of the idea. What we're gonna be providing, aside from like the like edge nodes, is gonna be a central node, which is gonna like support computing power on the lunar surface, and it's gonna create a cloud environment where all missions are gonna be supported. And more than a cloud environment, this is gonna create an ecosystem, a standardized ecosystem, which is what NASA wants with the Lunar program. And
Mm,
it's gonna be able to communicate with orbiters, such as like Lunar Gateway, initially, and then hopefully like uh, more. But to like to first deploy a system, it's better like to be ground based because it provides like full coverage of a specific area, and
mm,
yeah, and so
Definitely.
yeah, the creation of this ecosystem is very important to like foster like collaboration between like different commercial entities, but also different governments. We want to like we started like we got registered in the ESA, European Space Agency, earlier this year. They have another program, and what we want to do is like bring everyone together within LunarNet so that we don't have discrepancies, such as like what happened with like I think it was the 90s with GPS and Galileo that the United States had to send representatives around Europe to tell everyone, please use the GPS that we have in place, don't use your system. Yeah, ideally, we don't want that to happen again for the moon. It's good for redundancies, but it's good to like all collaborate on a single system to be in peace in place.
Yeah, definitely. Our systems are scalable. So we're starting with five or six. We're still not 100% sure, but we're working on it. With five or six rovers that they have antennas on them. So we don't really want to call them rovers because it's very confusing. So we call them mobile stations.
Okay.
But then, yes. So the way that our software architecture works is that it's autonomous and it's scalable. Is autonomously scalable. And we can add as many as these rovers as possible as we wish. So if the let's say there are more operations on the other side of the moon and we just want to expand it, we can definitely expand it depending on what range we're going to be getting. We're still doing more R&D on the range because the environment is very different on the moon. So the range that we get on Earth is probably going to be a little bit different. We're not 100% sure how exactly how different in terms of how many kilometers it's going to be reduced.
Right.
But we definitely have some benchmark data to go based on. So yeah, we definitely can expand the system as much as we want and create more redundancy. As more mobile stations we're adding, we're also going to have redundancy in the central communication server, which is the brain of the system. Even though that's the single source of truth in our architecture, but we have redundancy, so we'll automatically switch to the other one. But yeah.
That's really cool. I mean, one of the things that I've thought about with, we're taking these first big steps, right, of making this routine. And one thing we've talked about here on the podcast is the space conundrum, and when things for whatever reason seem to be going uh more chaotic in real life, like during the first space race, we had the Cold War, we had a lot of civil rights stuff happening in the country, and then we also had all of this stuff happening in space. I don't know why the two are related, but progress and chaos in life seem to be seem to be related. And so this idea of having consistent funding over and over again to have, the perfect program to set up, what you would ideally want to do, which is kind of what the Apollo program was so lucky in that it had. It had the national defense budget behind it. So they could do so much. But even that ran out. So my point of bringing that up is the way that you guys are introducing the system is it it doesn't require some huge Goliath thing that we're trying to, lurch forward into the future, set up the perfect network. You guys are setting up something that can build over time, and and of course, stop me if I'm wrong, but if you guys are doing, you know, uh, the the same platform as say what SpaceX and Starlink and these types of things, which is less expensive tech that allows for mass scaling of it. But you can also, if the program has a moment where, let's say, funding is drier, we have to select and focus, you guys can drop GPS or LPS wherever, the mission is going to be, whether it's just the South Pole, instead of sending a whole bunch of satellites that are going to, stripe out the whole moon in order to
Mm.
provide coverage. That's a lot of satellites to launch as opposed to, a few mobile platforms on the surface where you need it. I think that's really cool for mission architecture, planning in the future.
Yeah, yeah, that's correct. That's the whole idea.
Hmm.
Yeah, as we said, this is primarily envisioned to like prepend the timeline, and then it needs to like it's designed to be integrated either with like more mobile stations, mobile platforms, and future orbiters around the moon. So the architecture is like um, very reliant on artificial intelligence and neural networks. So that this is a system that, like you said, it builds over time because it learns. The more it is on the lunar surface, the more it learns how to adapt. And this is interesting because since the center of the computational power is going to be located at the central node, if an orbiter connects to a network, they're going to be able to like utilize the same and learn from the same data that our system has learned over time. And so
Right.
they're going to be, yeah, so they're going to connect to the network and be more ready to go. So yeah, this is something that operates very much like a human brain.
Mm.
And I think NASA recognizes actually this need even long before us. They had they felt this need, but lucky for us, no one has ever designed any system for it because no one has ever taken this seriously.
Mm.
Like you mentioned, we're going to be needing between 20 to 50 satellites, and look at the cost of building such satellite to being in lunar orbits. It's not just like in Leo or you just
Right.
park it in geo and you don't really need that much of fuel to burn. In the for lunar missions, you're going to be needing huge amount of fuel to stay in the orbit, and building those swarm of satellites is just not going to be economically feasible, and that's why NASA knows this. However, like I mentioned, those satellites and hopefully also the lunar gateway is going to be there in a couple of years from now. Those are going to be very, very beneficial in terms of the routing of the data between Earth and the Moon. So even though we're also working on laser communication, but for redundancy purposes and maybe not only for redundancy purposes, but also maybe there are some other, not maybe, but for sure, there are some other use cases of
Mm.
satellites being complementary to our system. So
Right.
yeah, definitely has to be a collaboration. And that's the whole thing. We're trying to get more companies and people into the industry
Mm.
to collaborate. And basically that's how we make money. We connect all of them together, and
Right.
by creating that collaboration, that environment, that ecosystem, as Luke mentioned, um, we can make money off of that, and that's basically uh,
Mm.
what other companies they want. They want collaboration. If there is one company drilling, but they don't have the technology to, let's say, use it for some reason, maybe they would just drill it, analyze the regolith, and that's it.
Right.
But what if another company can come in and do something with that? They can drill, they can extract some precious material, and then another company will just use it. So there is going to be a lot of communication between them.
Mm.
And think about that communication of like people sitting on the on in the ground segment on Earth and just deciding, okay, what should I do with this? Let me just go to my C3, which is C2 or C3 command and control software, and just click on this one like manually just to go. Okay, let's just go X I don't know XY. Let's go 2 feet, and now wait like 2 minutes to see what happens. So we just like
Yeah.
automating all that process together. So
Mm.
companies they can collaborate without any delay, without any I guess like uh, extra costs rather than the price that they pay for our systems, which are going to be very small and minuscule compared to if they wanted to develop it themselves. So even
Right.
if they wanted to develop something,
Right.
let's say it will just cost them 30, 40, $50 million more because now they have to develop a better let's say thermal system or power system, BMS, and all those kind of
Mm.
subsystems that they have to upscale because now they have a much larger data handling systems and communication system, more expensive antennas, and so on and so forth. So we're just providing them with that instead of spending $50 million on R&D and manufacturing. We're only charging them a few $1 million, but also in addition to that, we're enabling them to collaborate with other companies, which they couldn't do. Even if they built the
Right.
best communication navigation system for themselves, they still couldn't connect with other companies. So we also actually prevent disasters. So if another rover, if they're close, let's say there are some missions that are close, they're nearby. Another mission, they have let's say a rover that is moving, and another rover comes in and collide with that, which is a possibility in the future, in the next, let's
Mm.
say, 10, 15, 20 years.
Yeah.
That's going to be a possibility. There are going to be hundreds, if not thousands, of rovers just roving around. So there has to be a single source of truth to monitor all these
Mm.
things and making sure that with that planning that they have, like I mentioned, it's not going to be like, hey, push a button and just like on Mars, let's just go like 10 feet forward and then stop, go to the left or something. It's
Mm.
just going to be it's going to be real time.
Mm.
So they're going to be autonomously moving. So we got to make sure that we're monitoring that. And Actually, we're not monitoring that, but we're giving this feature to our customers and agencies, let's say Space Force and NASA, to also monitor them and control them if necessary.
Mm. And I just, as you were explaining that, I just realized that, once you have this net down on the ground, it can move and adjust,
Yeah.
along the way. That's a whole other capability. That's such a simple thing that we don't really have that often. And the idea right now of, even how I believe this is how it works today, but you know, satellite detection and stuff right now and managing all that traffic up there. If there isn't good communication between the different groups, a disaster could happen. And so, going on the moon and you've got this mix of private and public and then publicly funded private companies and all the different scenarios, that
Mm.
is a lot of different systems that could exist. And so think about the problem now where we have near misses with organizations that are trained to work together. What happens later when this boom happens and we're playing catch up the whole time?
Yeah. That's
Yeah.
also a problem that like modern day militaries have. Sometimes like two units they miscommunicate and they end up like in the same place because there's no single source of truth. Like binary can they operate on different frequencies. Well, that's a broader topic and that's for safety reasons. But yeah, it happens even in that environment, and we definitely don't want that to happen on the moon when there's like uh, millions, if not billions of dollars of equipment going around. We don't want to like, yeah, waste that on car crash. So we want to like prevent that.
Yeah.
And yeah, we want to prevent, what we're going to do for companies like provide like an abstraction, like by abstraction, I mean, when we're driving our car, we don't need to know how the car works. We just turn it on and drive.
Mm.
And that's what we want to provide for companies, just like, plug it into our system and play. So
Plug in and play. Exactly.
yeah,
Hmm.
yeah, we use that word a lot, like just plug in and play. We try to make everything plug in and play just as simple as possible.
I like it.
So the smallest thing to like the bigger thing. So yeah.
Yeah, and it feels like once you guys get enough people using it, I mean, I would think the next stage is, especially since, you'd be working within a somewhat NASA infrastructure, at least with them, like then NASA could start recommending that on any spacecraft that go out there. So it becomes a requirement for, a certain
Yeah,
type of funding or a program or something like that.
absolutely,
Yeah,
Yeah.
absolutely. Yeah, that's
definitely.
what we're aiming towards, and that's what NASA's looking for. So yeah, this is gonna be like the direction that the lunar environment is gonna go on.
Mm.
So yeah.
Well, I want to touch back on the AI aspect because I think, I mean, it's in the lexicon, it's in the zeitgeist, it's, you know, um, the one thing we don't want it to become is magic, right? So that's not scientific, and the more we can understand it, the more we can do with it. Um, so right now, are you guys building out artificial intelligence that you're prompting and learning currently, or is that still something in development?
I'd say we're developing it, but we've actually successfully deployed it. Um, like as we said previously, we're building something that operates very similar to a brain,
Hmm.
so it is predictable, and I don't think it's ever gonna be not predictable in that case because I mean, for it to be not predictable, you need like a huge data center, and
Hmm.
a huge data center on site that communicates like continuously with it. And that's not going to be the case on the main. The data center is going to be
Right.
enough to support operations. And then most of the computing power is going to be done back on Earth, but it's going to be updated. Like updates are going to be done like remotely. So we will always be able to like control what's going on. So and also what we want to we have like a prevention measure in place that it's called like just avoiding zombie nodes so that the
Okay.
node just doesn't like start ruined by itself. And so yeah, it's very centralized and it's very secure. In terms of like AI is something that can learn from the environment, not something that necessarily like thinks for itself. It's something that
Hmm.
becomes smarter and smarter. And yeah.
We're also very big on cybersecurity, and we have a great team. Uh, so yeah, we're definitely incorporating a lot of their experience into our systems, and we just want to make sure that our systems are as infallible as possible.
Hmm.
There is not such a system as like secure, 100% secure, unless you just lock it down,
Right.
which in this case probably not going to happen. But we have some ideas of how to lock it down in a way that we will only provide those kind of local internet for our users, and then it will be connected to Earth through a different channel, and then that channel cannot just access the data of our clients easily. So we're working on that. It's still in progress. It's still in progress in our R&D phase. But yeah, we're making a lot of progress on that.
That's cool. I mean, the more I learn and read about AI and use AI tools, like we'll be using that for this podcast to help me with editing, from an individual perspective. It's already been an invaluable tool. I mean, I've saved hours of my week preparing for the show thanks to AI tools. And to think about what it could do for space travel, we always had, the ship is a computer that speaks to you, like that's a pretty classic sci-fi trope. And to think now, there would be all these different AIs that could potentially merge into, whatever ends up running, or maybe they all work together on that system that keeps us alive as as we're in space. Um, to think about how much work is and collaboration is going to go into that and what comes out of that keeps us alive in space is kind of crazy to think about.
Yeah, I
Yeah.
think it's an integral part of the space, space technologies. It In the future, we're just gonna see huge, you know, progress on like AI and machine learning. And I think without it, we definitely cannot be achieving what we want to achieve to, put a
Yeah.
million people on Mars, and, traveling between, 4 months to 9 months, depending what kind of technology we're going to be having. It's still, even if it's 1 week, you need AI to
Mm.
accommodate you on board. In terms of entertainment, in terms of, let's say, keeping you alive, in terms of a closed loop ECLS system, because for the most part, you just cannot have like a life support system that is just open, like on
Mm.
ISS, for example. So without AI, having a loop closure ECLSS system is almost impossible. It is definitely possible, but it's just not going to be as efficient, and
Mm.
probably going to be very costly. It's going to take a
Yeah.
lot of space and so on and so forth. So yeah, AI is definitely going to help tremendously in in the coming years. So yeah, definitely.
Yeah. The thing with AI is that it simplifies things and it simplifies like usage. of something like anything. So that's what we're moving towards because it's efficient and it works even like computationally. Um, it most AI-based solutions, yeah, at least like for our branch of research, are more efficient than like algorithmic solutions. And thinking in the broader spectrum. So that's also why one of the reasons why everything's moving up towards AI and also towards like quantum computing.
Mm.
Yeah, and you mentioned something about like you personally using it. And so for example, in generative AI like ChatGPT is very efficient,
Mm.
but it makes a lot of mistakes. So
Yes.
now you got to find that balance of
Mm.
reliability versus efficiency. We haven't even got there yet. And as you can see, in ChatGPT, we just always say that ChatGPT can make mistakes. And I think that's gonna be like this for the next like decade or so. We're not gonna have a perfect AI system. We're still gonna improve it, especially in generative AI, which is gonna be integrated into, let's say, spaceships,
Right.
to talk to someone, right?
Right.
You don't want to be in isolation. You want to talk to someone, and probably AI is just gonna make a lot of sense in that realm in terms of astronauts' cognitive health. So,
Yeah.
but we're definitely not going to get there earlier than, let's say, a decade from now or so to have a perfect system that doesn't make any sort of mistake. Because even one mistake out of 1 million answers or something like that can be devastating,
Yeah.
especially if you're talking about non-generative AI that is designing a rocket. And
Mm.
I think I can talk about that because that Ask Me Anything from the new CEO of Blue Origin was uh, was published.
Mm.
So someone just asked the new CEO, "Hey, are we gonna have like AI implemented into like our manufacturing system?" And he said, "Yeah, definitely. We're working on that to make that a reality. Of AI will just design the rockets and find the most, I guess, like the most efficient way of achieving something." And
Mm.
as you can see, even without AI, we're achieving a lot of progress. I don't know if you've seen the new engines of Starship, if I'm not mistaken.
Oh, they're so
The
beautiful.
version 3, yeah.
Yeah. Raptor
So
3.
super, yeah. Raptor 3 ones, they're super, super slick, and all that redundancy, all those tubes and everything is just gone. Think about AI saying that, oh, actually, you don't even need half of it. You can just achieve the same thing or even better if you're
Right.
just doing it this way. And that would be in just a matter of few minutes that it will just make that decision, design everything for you.
Yeah.
So yeah, we're definitely gonna see a lot of changes, but in my opinion, it's just not gonna happen because of the mistakes that AI is making.
Yeah, and I definitely the curveball I did not expect when it first came out was that it would give an answer just because it was asked to give an answer, and essentially I don't think it was doing it on purpose, but it lied to us. You know, so it's an interesting challenge that I never would have expected out of something in my mind of AI. And I'm still playing with this thought, but I wanted to know what you guys think about it, especially since you guys are involved in developing your own. Um, I think with generative AI right now, we talk about the single source of truth or just truth in general. I think AI proposes a very strange challenge for all of us as it gets better and better. I mean, I saw a video. Again, I don't even know if it's real, but I saw a video that someone posted that was entirely AI generated, no voice, but it was a woman who was talking on stage, and I kept looking for flaws and I couldn't find one. Um, so what do you guys think about something like a tagging system? Like I think I've already seen it. I know on YouTube you need to tag if there's AI generation. Um, it's a weird problem, right? Because in some ways I think it's good for everyone to know like this, it might as well get the credit, right? It was generated by AI, and we're kind of in this training race of data for all these machine learning systems. Um, do you think it's a good thing to tag everything that's AI on the internet as AI? Or what do you guys even think about that proposal? It's an idea I'm throwing out there.
I personally think it's correct because I mean there's a huge problem that we're trying to tackle as humans, I would say, regarding like the ethics of AI. Uh, right now, I mean companies have been trying to develop like Amazon and Microsoft have been trying to develop AI systems, and sometimes they had to scrap the project because I mean AI with at uh, was like running into like problems of like not being able to like break from like social stigmas and
Mm,
being like because the data it was being fed to was like faulty and well I wouldn't say faulty even if you polish it you try to polish it
just
as much as you
biased.
can yeah
Yeah.
it's biased from what what's been going on like in our society so in case of like an AI for HR, and sometimes there's been cases where the AI used to like favor, um, I don't know, white women candidates, and that's not fair. And that is something that needs to be like addressed by in regards to the ethics of AI. And
Mm,
Congress is actually working on it, and like top research institutions are working days and nights to like tackle this problem because I mean AI is getting developed regardless because it's a huge source of like income for companies and it's something generates revenue. Um, there's gonna be some people that don't care about the ethics behind it. And if we want like if we generate an AI, I wouldn't say like evil because I mean it's got no feelings, but which is faulty, which makes biased decisions. That's dangerous for what it could become. And also, like if that data gets sold to generate like another AI and so on and so forth, like the escalation could be like exponential. So yeah, we need to be careful about that. Regarding the videos, I think that's just that's slightly of a simpler matter. I think it needs to be tagged as like AI generated, because I mean we're not gonna be able to like tell the difference, and it can be used for like in bad cases. And that's something that should like start from like the AI generation tool that like generates
mm,
a content that is not correct. It should recognize that the content is not it's not good, and it should not make that content to like start with. And also like the platforms in which this content is shared on, they should be able to like monitor all of this. So yeah, at least for now, it should be marked as AI generated. I don't know what your opinion is on this.
I don't think there is any tool as of today that can recognize like a counter AI that can recognize
mm,
an AI generated content. Of course, there are a lot of patterns. For example, in ChatGPT, you see ChatGPT will never just say, "Hey, there are some contracts such as this and that." It will always say like. So
mm,
this like, and then it will just continue. And there are a lot of commas and then ings and things like that. There are some patterns in ChatGPT, especially in the previous versions, but it's getting better and better.
mm,
And I don't think anyone can actually like build, I guess, a tool that can recognize it. If someone could do so in a way that can catch up with the speed of development of AI, that would be a brilliant idea and a great business idea that you can make billions of dollars out of it. But I don't think there is
mm,
any way to catch up. As of now, maybe you could.
right.
And I remember Elon Musk's, I think it was Tesla. I think it was first, it was uh, SpaceX's YouTube channel that got hacked. And
Yes.
yeah, and then it was Tesla a couple of weeks ago.
Mm,
I think 2 weeks ago or something like that. And it's just so surreal. Like Elon is just talking, just so surreal until uh, you just notice that these are scammers. For
yeah.
a lot of people, they don't actually recognize it. a lot
Yeah.
of people. And I've been watching a lot of these videos that are just busting these scammers, specifically in India.
Mm,
But they're making billions, and that's an issue. So
yeah.
that AI is getting into that industry as well, to the scamming industry.
Mm-hmm.
And I think it's going to be huge. So, I mean, if you have an idea that can recognize this kind of like AI generated content or phone calls or something like that, you're a billionaire, maybe a
Yeah.
trillionaire.
Yeah. Yeah. You heard it here, folks. So if you want to jump on that, go for it. I'm too busy. Um, but yeah, it's fascinating, and it really makes me think about the core of it, right? We talked about that earlier, that we've got problems with this being biased, and at the end of the day, you know, we're the creators of it, and we're biased. So how
Exactly.
unbiased can we really expect um, AI to become, especially in the early days? Um, it's just so interesting. Like even now, when I search for something on a browser, the first thing that pops up is the AI explanation, and I am doing my best to scroll past that every single time because I just don't want. It's just not. I don't trust that data set yet, and that's just the
Mhm.
engineer in me, and I'm glad that people are trying to push it to get this revenue generation going. But, you know, the people that are writing it and the people that are driving it, it'll be interesting to see if we can get more and more people to talk about their maybe philosophies behind it. I think that could be really, um, really beneficial just to help people understand. Um,
Yeah.
it's assuming people want people to understand, but that's a whole other topic. Um, what else, guys? What else would you guys like to close with? Is there anything else in the short term that NAVXCOM is looking to do? Anything the folks can look forward to, or maybe help join in?
Uh, uh,
Sure, I guess. Yeah.
oh,
Go
you
ahead.
want to go ahead then? Yeah.
Yeah, well, I was going to say that we are working really hard to get as many as passionate people and new startups to join our I guess collaborative efforts for the infrastructure, especially those younger generations that they're brilliant, they have amazing ideas, but they're just scared that, hey, how can I just manage a company like space companies? It just requires dozens of millions of dollars to do something. No, it doesn't. You can just get started with something like SBIR and build your business based on that. So we are really working hard on that. But also we're also working on some other technologies besides this lunar, NAVCOM system. Kind of some of them are related, and we can incorporate it to our ecosystem. But some of them are completely separate from the lunar applications. So after all, we're a navigation and communication company, and not specifically to space, but we're super passionate about space. And I think even these lunar applications that we're developing, they have a dual use, if not triple use on Earth, on Mars, and also on the moon. So I don't know if you have ever heard about network in a box technologies,
Hmm.
that they do actually have them. We do actually have them on Earth. It's mostly used for GPS denied environments. So our
Oh.
system will just improve that network in a box functionalities that we currently have, especially as Luke mentioned, the the autonomous deployment of it in some areas that humans can't get there, but rovers can, or some other systems
Hmm.
maybe drones can get on Earth. So our network architecture or software and also our hardware can just improve that those kind of systems on Earth as well. So we're working diligently on this project, but also on other projects to solve other problems that no one has ever solved, and we're finding gaps when filling them up. Some of these ideas, some of these technologies, they're in ideation, some of them they're in development, and some of them super close to commercialization. In just a couple of months, we're gonna release two products that we have. We're working with an R&D company, and these are significant changes in the state of art. and we hope that the revenue that we get from those kind of products or services uh, help us just develop these lunar applications, lunar NAVCOM systems. So yeah, we're working really hard on that, and we're not gonna stop. We're gonna do it. A lot of other companies and countries and organizations, they're gonna join us, and we're gonna see a very bright future in the space industry.
Yeah, and this is also like the beauty of like space research because I mean the other project that we're working on are like spin-offs from like the space technology that we're developing. So it was I don't know if it's true anymore, but it was saying that $1 invested in space brings back $10 on Earth.
Yeah,
And yeah,
I heard that one too.
yeah, I don't know if it's true anymore, but maybe it's even higher because of inflation. But um, the yeah, like investment in space brings like because I mean it's such a different angle to like tackle technology problems. That thing you can just apply it on Earth and be like, oh, this is way faster to like integrate. It's just way easier, way more customer friendly. Like anyone can use it. So yeah, there's a great spin-off. So of course, I mean, commercializing is a whole other challenge, and we're also
Mhm.
working on that. But it's great that space research funding gets these opportunities to us here on Earth to benefit like life like every day and not just like life like 5 years from now necessarily.
Right.
So yeah,
Yeah, I think that's one of the challenges with a lot of space technology, and I think we live in an age right now where, you've got SpaceX is launching more things into space than we've ever launched before just by itself. But then it's also putting up satellites that's helping, people get internet. In some places it's cheaper to have Starlink. In some places,
Yeah.
you basically would need satellite internet anyways, and they're
like,
they're able to deploy it. I mean, it's going to places that have natural disasters. Obviously, in Ukraine, it was deployed. So it's touching everything,
yeah,
and it's helping fund the future programs that they're going to do in space. So I love that you guys are doing that and providing value today instead of waiting for tomorrow, which is, I think, very new in the space industry.
Yeah, definitely.
Hmm. Well, cool guys. Any last words for the folks out there? This was a absolute pleasure. I want to have you guys back on again when you guys have those products out. But yeah, any last words?
I guess from me, it would be like I mentioned before, please, if you have ideas, bring it on. Just search for programs that NASA has, for example, or DoD, SBIR technologies, a lot of them from Air Force to Space Force, that you can bid on those. You can learn how to write proposals, or there are some other companies that they will write the proposals for you. Just sign an NDA with them. They will take care of everything. And there's a very high chance that you're going to win those contracts. As an example, SBR will give you $150,000 roughly. Some others, let's say sometimes Navy $250,000 or Army. But in general, you will get about $1 million to develop your ideas and commercialize them. And then also the government, especially in this realm, NASA will just help you commercialize it,
Mm.
and then connect you with the industry leaders to develop those and commercialize them to a point that it will contribute to the economy. Um, on Earth and also in space. So yeah, definitely get there. Like if you have ideas, please bring it on. Start your own company. It's not that difficult. Just watch a couple of YouTube videos. ChatGPT will help
Yeah.
you tremendously. There you go. And yeah, definitely, please get involved and let's just build a better future for humanity.
yeah. Starting is not difficult. To keep going is like that's a different fact, and that's where like you see the difference in like companies that succeed and fail, but also like individuals that succeed and fail. Um, so yeah, definitely if you come to either like anything, like from starting a company to anything that just get started and then just keep going and yeah, trust your vision and yeah, have numbers to
Don't
back it.
quit.
That helps. And so yeah.
Just don't quit. Yeah, just keep going, keep going. If you feel like your ideas are worthwhile, they will fill gaps. Go for it. Don't quit. Just be resilient. Push. And be coherent, and you're gonna get there definitely. The cool fact about the new space, and some people call it space 3.0, and some others they just go to like 8.0, 9.0. The cool fact is that not even the sky is the limit, the space is the limit. You can make money off of pretty much everything in space, especially in the new space. There are so much opportunities, so much. You can open an ice cream shop on the moon. I'm kidding, but